Hi guys, in this video we study what is iterating, splitting and slicing in number. How to iterating and then we will split and then we will stack and then we will know how to slice in numpy. So first of all what we do is we import numpy as np inside our collab notebook. And let me tell you what does iterating means. Iterating means repetition of anything. We want to repeat a thing a number of times. We use the iterating principle in Python. So first of all what we do is we create a 1D array and we store it in a variable named p1. So if we run it, it gives us an array from 0 to 9. And then we create a 2D array, and that array we store that array in a variable named p2, and that array is a 2D array from 12 till 24, and 24 is not included, and we reshape it into a 3x4 array. Similarly, we create a 3D array. We store it into a variable called p3, and this array consists of two 2D arrays, and this is seen like this. And for using the iterating principle on 1D array, what we do is for I in p1 we call this function print I. When we print I, it will print all of the items present in p1 array one by one. Similarly, if we want to print a 2D array, we would use for I in p2 we will recall the variable in which we store the 2D array, and then we would print I. This prints out all of the 2D arrays one by one. Similarly, to print a 3D array, what do we do is for I in p3 we recall the variable in which we store the 3D array and we print I in it, and that is so a 3D array has been printed. And if we want to print every item in p3 one by one, this is a problem. So how can we print every item in p3 one by one? We use a function called np.nditer. This function is basically used for printing every item in an array one by one. So for I in np.nditer p3 print I, and it prints out all of the numbers elements present in p3. So how to find transpose of an array or a matrix? For transpose we use we call the attribute dot t, p3 dot t, and the transpose of this matrix is uh, shown by this attribute. So there's another function called revel. What does a revel do is it converts a multi-dimensional array to a 1D array. So what's the multi-dimensional array? Multi-dimensional array is also called a 2D array, 3D array, or it can be any dimension of array, 4D array, 5D array, 6D array. So here we have converted p2 into a single 1D array. We call the function p2.revel, and it basically makes it into a 1D array. And similarly, if we want to convert p3 into revel, first of all I will have to import numpy as np, because this program was written one day prior, and then I will have to run all of these functions one by one just to make sure that it runs. Okay, so after running all of these functions, let's run this p3.revel, and let's see that it has converted all of the items in p3 into a 1D array. So a 1D array is shown. Next comes the concept of staking. So what is stacking? Stacking is basically joining two or more matrices. Uh, there is a simple rule that must be followed in order for doing staking on matrices. Matrices are also called array, so I will use sometimes the word of array and sometimes I will use matrix. So matrix, both the matrices should be almost of same size. Like if a matrix is of size 3 by 4, then the other matrix should be of size 3 by 4. So we create two matrices that are of equal size. We name one matrix P4, and that matrix is shown that this is a 3 by 4 matrix. Similarly, we create another matrix that is P5, and we the size of P5 is also 3 by 4. So both of the matrices have same size. So what is basically staking? Staking is considered that I have written P4 on one side of paper and P5 on other side of paper. What do? Is we just join them and make them one matrix. So for that, there are two methods in uh, staking. One is horizontal staking and the other is vertical staking. So what is horizontal staking? Horizontal staking is basically joining two matrices horizontally. Like there is a matrix P4, P4, and this is P4. Let me highlight it for you. Now till 15 and the two rows below it. And this is P4, and now I am highlighting P5. This all is P5. This is P5. So both of the matrices has been joined uh, uh, horizontally, and for joining two matrices horizontally we call the function hstack, and both of the matrices must be stored inside a tuple. This is the basic syntax of horizontal staking. Similarly, vertical staking. In vertical staking, what we do is we join two matrices vertically. So you can see this is P4 and this is P5. Both of the matrices have been joined vertically, and they have been converted into a single matrix. So the next principle comes the principle of splitting. What is splitting in NumPy? Splitting is basically used to split arrays. It has similar to staking, sorry, opposite to staking. It has two types: horizontal splitting and vertical splitting. It is like we have a matrix, we have an array, we want to split that array into two ways. So into two halves, or maybe four halves, or maybe eight halves. So there are two methods through which we can split an array. One is horizontal splitting and the other is vertical splitting. So unlike horizontal staking, uh, what uh, what is done in horizontal splitting is like both of the matrices. So we have split here in this problem we have split P4. So what has happened is basically we have split P4 into two parts. So let's see, let's call P4 first. Let's see where is P4, and so this is P4. So basically this is P4. So now what has happened is uh, to split P4 into two parts, this 12, 13, 16, 17, 20, 21 has been made one matrix, and 14, 15, 18, 20, 19, 22, 23 has been made another matrix. So this is how horizontal splitting works. Basically it splits two matrices horizontally. So vertical splitting is basically joining two matrices vertically. For vertical splitting, we use the function dot vsplit, and inside that we now split P5. So for vertical splitting, the scenarios are a bit different. So what here has happened is we have split P5 into three parts. So it has basically it has all of its rows splitted. What if we split P5 into two parts? What will we say? This is interesting. So basically it will show an error. Why it has shown an error? Because P5 can practically not be split into two parts because it consists of three rows. So if we split into six parts, what does it say? There's still an error because uh, uh, like there is another error, like p4 is not defined. So first of all we will have to define p5. I think this was not defined. And now let's split it. So now if we split it, so does not result in an equal division. So P5 cannot be splitted into 6 parts. So let's see how many parts it can be splitted. So where is P5, 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 here is P5. Like this is P5, okay? So it's a 3 by 4 matrix. So let's convert this into a 6 by 8 matrix. 6 8s are 48. So we'll need 48 numbers for that. And let's rearrange this. This will be a complex matrix. So basically, so this would be for that, for making a 6 by 8 matrix we would need 40, we would need np dot range. The range we put must be 1 comma 49, like include 1 and do not include 49. So now what do we do is we split. So it has got like 6 rows. Now we uh, split all of the rows. So for splitting all of the rows, here we will give the argument 6. Now if we run it, it will split all of those, like you can see all of those matrices, all of those rows are separated, and all of those. So this is how vertical splitting works. Peace out.